Okay, today we're going to do an exercise here, and this is going to help a lot because if you review this, you can apply this information to a whole bunch of different scenarios. We're going to have a little pretend scenario here, and what we have is an aviation map, and this is Montreal up here, this is upstate New York, these are some mountains over here in Maine, and Vermont, and so on. So basically we have an interesting map with a lot of information on it. Now, the topographic map, as I suggested in one of my other videos, you get a map of the whole area that has all the topography and the elevations, but on an aviation map you can get a good idea of the elevations. It may not be as precise as far as the elevations. It doesn't have as much detail as an ordinary topographic map. But this is my preference, the aviation map. Now, the first thing you got to know is where you are. I mean, frankly, any map at all is better than no map, assuming it's even halfway decent. But the more information that you get on your map, and here I have it map on my table here that's oriented to due north, that is true north. This line right here on this map, which is lining up with my true north of my compass, and I've already corrected it for declination, of 14 degrees to the west, which is the area here, and that's another important piece of information that is found on aviation maps. For example, if you look at the airports, and there's a beacon around some of these airports. I'll show you over here. They have what they call a radian. And around these things is a 360-degree arc that shows where true north is. And then you line it up. Here's one over here. You line this up over here with the magnetic north and true north. And then you can decide where your magnetic direction is. Now, in this case scenario, let's say pretend that something's big happening, there's a big storm or blizzard or something, and a lot of people are going to want to escape Montreal, and some of them are going to go up this way, and some of them are going to go down this way, and maybe they want to get to some higher ground or something, and you're also thinking about possibly getting to some higher ground. So you say, well, where can I go? And you don't want to go off to the southwest because you got to cross this big river here, or this big lake, so that's not a very good option. But you have some higher ground much closer here. Now, what you do is you get this information, we'll line this up here with the magnetic north, and then you start getting an idea. Well, okay, how far is it? Now this map has different denominations. Now this is a 1,000,000 to 1 scale, and this is a 500,000 to 1 scale, which is this map right here. So I use this, and I know where about a nautical mile is, and how many, let's say that's about 50. And 50 nautical miles is something like 65 or something like that, regular statute miles. And so you want to figure, okay, well, how long is it going to take me to get there? And then you start saying, okay, let's say I want to get over to here. I want to get maybe in the shelter over here. I want to get in this valley on the other side, the eastern side of this mountain range here. And I'm going to go in this area here, for example, and get away from this storm, this theoretical storm. So now you want to get like a true line, an accurate line that goes in the direction that you're trying to get. So you mark this over here, and you make a line on the map. Now, as far as like your car, let's say in this case, we have cars. Let's face it, we're not going to be hiking, most likely. But you want to start looking at what roads go in that general direction, and what type of roads are they. For example, here's a small pass between two small peaks. So there's a pretty decent road that goes through here. It's not exactly at the right angle, but it's in the general direction. And so what you do is you have to figure out how to make the connections, and by constantly if you follow the bearing all the way around, eventually you're going to get to this direction. If you get off course a little bit, you keep correcting and try to triangulate. Now, one of the ways that you can use these instruments, let's say for example, you get to a certain situation and you don't know exactly where you are on the map because your GPS isn't working. So you might take a sighting with this gadget here, or this compass, and look at this mountain here, and then maybe there's another place over here where you can sight maybe a beacon or something like that, another peak, and then you make a line, and you intersect those lines, and you figure out almost very closely where you are. And that's how they did aviation for a long, long time. They actually had to fly kind of by the seat of their pants. The wind will carry you aloft and so on, and you have to navigate and consider all these factors. But this type of scenario is something that's very practical. It could easily happen. And if you decide, for example, that you get your compass out and you say, well, okay, I want to be I want to be over here. But because you're going on the true north and you don't even know exactly how to follow your compass, you're thinking that this is the true north and magnetic north the same, you're going to end up like way off the map. I mean, you're going to end up really in the wrong location. So it's very, very important once again. Now, there's all these different kinds of compasses, and this one is really great for hiking because you can, as I illustrated earlier, sight down the line here and take a bearing. But if you don't know how to use a compass, you're going to be at a real handicap. Now, a map is better than nothing. If you have a map and a compass, you're really, really in good shape. Now, here's a little device that I suggest people get. This is has a little scale on it, and this little wheel turns, and you follow a road, for example. You don't have to measure by the crow flies or just straight line. You can actually draw this along a road map, for example, and then you can turn it over and you can look at the scale and you say, well, that's so many, inches or whatever, and you use the scale on the map to convert it to figure out exactly how many miles you have. And that's a very useful device. Now, this is another aviation tool, as I illustrated. It has a 360-degree protractor there, and it has some other scales that are used in aviation, but you can look at this, for example, you can aim this north at magnetic north, and then you can see all the different magnetic bearings around there. Say, well, if I follow the 70th bearing magnetic, I'm going to end up over here. So in this case, let's say we've got this corrected for 14 degrees, I'm going to go over here, I'm going to point this, and I'm going to look at this angle here, and it's say, if I follow, say, 100 degrees magnetic, off to the southeast, slightly to the southeast, I'm going to end up right over there. And that's one way, and I suggest you also get pencils. Here's another device that's also very handy. This has a thermometer, and it has a wind meter. It can do a peak wind and an average. And this is very useful to see where prevailing winds are in case certain storms are coming, or clouds, or dust, or something like that. Now, again, there's other different kinds of compasses. That's a simple one. Here's an old one that's in very good condition. It's a German one, German made, and it's got nice glass on here. It's fairly simple, but it has little dial here that you can set your course, and you have some luminescent little particles here that you can tell where things are in the dark. And I'll illustrate some of these other compasses in a future episode, but just to get into this one a little bit, for example, this one, instead of having a glass mirror, it's polished steel, and what you do is you put up these sights, and you can aim this up at a distant, say, mountain peak, or you can look at the sun, and it goes through here, so it splits, and you can see how high in the sky the sun is, and that can help tell you the time of day or the latitude. For example, if you sight on the North Star, you can determine where your latitude by using this type of device. And there are times, if you know geometry and if you know algebra, you can take a sighting on a distant object and use a proportion based on a local object that you guess, say a tree is 50 feet, and you make a triangle and you do some algebra, and then you can find out approximately how high a distant mountain is. So that's the end of this segment here, and I have to make more videos because we run out of time. But there's a lot of really important information on these maps, and I'm going to go into it in other segments.